the x-axis, you would have to calculate what the slope would be to get that actual point. Don't just guesstimate. But the goal of this is actually just to use the graphs and not to come up with an equation. So it's not necessary to write an equation. If you were given a graph that you couldn't create an equation from, then you would have to use the graph and not kind of rely on trying to write an equation. So if you look at letter A, we have these two options here, F and G. Letter A says we have F of G of 2. So Brandon, what are you trying to do to use the graphs to find F of G of 2?
You find where x equals 2.
So this guy right here is x, exactly as we said. So you find when x equals 2 in which graph, Brandon?
G.
The G. So you're going to work inside first and find G of 2, which means find when x is equal to 2 in the G graph. So whatever you have inside, you're always looking at G,
And that's 0.
in this case of 2. And that's 0. So G of 2 is equal to 0. So you're finding the point on the graph, you're finding the y value because you have x. So then, you know G of 2 is 0. Now you're finding the outside part by taking the number you just found and using that with the f function. So now x is 0 with my function f. Here's 0, match that up with your graph, and that y value is 3. Anytime you're looking up something in the graph and you know the number in parentheses, you're always finding y, never x, because you know the input value. So travel to where x is in your graph, match it up, get the corresponding y value. You're done. So you didn't need to come up with an equation. You didn't need to do really any algebra, besides knowing what f of g of 2, I guess, meant. Questions? So letter B. How could we rewrite letter B? How else could you write it? What's the other way to note it? Do the notation that we know. Say again?
G of 2 plus F of 2.
Yeah, or f of 2 plus g of 2. Either way is fine. Virginia likes it being alphabetical. You're
That's
just,
not
it's not out. It is alphabetical. She didn't want it alphabetical.
oh, okay.
So we have f of 2 plus g of 2. Just like we did on the previous one, you're going to find the 2 value for x on the f graph, the 2 value of x, that x value, you're finding that on the g graph. So looking at f, you're going over to where it's 2 connecting, and that's a value of 1. In g, we already said that was 0. G of 2 is 0. And 1 plus 0 is 1. Questions? Libby, what's letter C asking you to do?
It's asking you to do the F of 3 times G of 3.
Right, so that is a times sign there. We're finding f of 3 times g of 3. Libby, what is f of 3?
3.
3. G of 3 is,
-1.
yeah, that's this number right down here, that y value. So that gives us -3. And then the last one, f minus g of 3, really says take f of 3 minus g of 3, which we just found those two numbers, so now we're just subtracting them. F of 3 is 3, g of 3 is -1. When you combine them together, you get 4. So not necessary to write an equation and spend time trying to create an equation, determining how it's moving left, right, up, or down, when you're literally just finding x, matching it up, giving your y value. Doing whatever it asks you to do. Add, subtract, multiply, divide. Questions? For whatever reason, these problems will trip people up tomorrow. I don't know why. It happens. Questions? Okay, so from any of the review worksheets, and there are 6 different pages, 2 different review worksheets, are there questions that you would like to go over? Great. Number 9 from
For
the second
number
one?
2, yeah.
Yeah. So if you look at the, if you look at the back page of the packet, the very back, bless you, Brandon is asking about number 9. So the last page of your packet, looking at number 9. A company produces a product for which the variable cost, variable means the cost is like changing based off of the number of products that you produce, is $5.35 per unit. The fixed cost, which means that doesn't change, you gotta pay that amount, is $16,000. The company sells the product for $8.20 and it can sell all that it produces. So whatever it makes, it's selling. Must be an amazing product, whatever it happens to be. A says find the cost function. So no, you don't need to know anything about accounting in order to kind of work through this problem. What would cost the company money? How could we write an equation for cost, Virginia? And I'm going to put a C for cost.
5.35 U plus 1,600 or 16,000.
So the cost would include $5.35 to make whatever unit we're making, whatever it happens to be this product. On top of that, we have to pay $16,000 probably for some kind of equipment to make the product. So our cost is $5.35 for every, I don't know, what can we make for $5.35? Stapler. Yeah, there we go. Sounds good. I think we can make that for $5.35. So $5.35 to make the stapler, each stapler, and then $16,000 for my machine that makes staplers. Probably exists out there, some kind of crazy machine. So that would be our cost equation. Part B says find the revenue equation. Revenue is how you are bringing money into the company. Cost is what you are spending, taking out of the company. So Brandon, how are we bringing money into the company?
8.2 U minus 5.35.
It's just the 8.20 U.
Oh, I was doing wrong.
You were doing profit. Yeah. So revenue is just how the money is coming in. What you're charging somebody for the stapler is revenue. So cost is the amount that you have going out. Revenue is the amount that you have coming in. So how you are bringing money into your business, into your company. So for my fancy little stapler over there, which isn't very fancy, I'm going to charge $8.20, which it's not really that great of a stapler. I don't know if it's worth $8.20, but we'll say it is. The last question then is profit. Profit is what every company wants to have. You want to have a profit in order to stay alive. Or you at least want to have break even, where the profit would be zero, because then you're not losing money, but hey, you're not gaining money. But you're not losing it. That's the important thing. So, Brandon, you were giving me the profit equation. So how would you actually end up making more money than what you're spending?
8.2 U minus 5.35 U minus 16,000.
Exactly. So my profit has to come with whatever I make minus the amount we're spending. Whatever's left is profit. And if we combine that together to simplify it, this is 2.85?
Yeah.
And then minus 16,000. So really, I'm earning $2.85 for every unit, taking the cost and what I'm selling it for into account. Every unit I'm earning $2.85. When that number of units gets to be a value that equals $16,000, anything after that that I sell then would be extra money in my pocket. Maddie, you can sit wherever you'd like at the back. Any questions with that? So profit is your cost minus your revenue. That's what you're truly earning. The profit is what you're truly earning, truly making after you pay for everything that you had to pay for to make the product. How about another question from the review? guys are really quiet today. Everyone okay? Feel comfortable with the test tomorrow? Then we can complete the square. You don't like it? I think you'll like it better the second time around. I heard Michael loves it. Completing the square.
I didn't know how to do it. Like in the summer, I had to Google it. I'm grown to do it.
Oh, but you Googled it and you learned.
Yeah.
So that's
But I
good.
don't really remember.
Oh,
I
okay.
forgot.
Oh, that's so easy though.
What? Yeah, it's okay. Well, me did not do it either. So he came to ask me to do it, and I was like, yeah, just give me a minute. I had no clue. I was like Googled it and then told her what to do.
Well, I am impressed that you Googled it and figured it out, Michael. You kept your notes. That's kind of key for next year. I'll tell you at the end, like, there's specific packets that you might want to keep for next year.
What about if there's still?
I think anything we cover this year covered anything that you did last year. But like there are a couple of things for next year. Your trig, the first trig packet, like you'll want to keep.
You're not gonna be teaching us next year,
No, I don't teach you. You need to have another teacher.
are you? Oh, come on.
I think you should just go up another lecture.
No.
Come
Too
on.
much.
Just teach it for the rest of our high school.
No.
Yes,
You'll be fine with Mrs. Everhart. She's amazing.
Come on.
She has a phenomenal AP track record. Just like barely anybody failed the exam. She's amazing. Yeah, you do. But she has an amazing, like 95% pass rate. She's amazing.
Oh, okay.
Like she is amazing. Yeah. See, now it sounds so much better.
But I'm gonna miss you.
All right, so completing the square, not everybody's favorite thing to do, I guess. I prefer it over the quadratic formula for probably 95% of the problems. The quadratic formula is good because if you're solving for x and it can't be factorable, you can use the quadratic formula. However, the quadratic formula is messy because it needs to be simplified. Most of the radical values are large because you're squaring a number, you're subtracting 3 values that you're multiplying together. So you have to simplify the radical, and you're dividing by 2 times something, so then after you simplify the radical, you have to make sure you correctly continue to simplify the problem
And
when you're
it's plus or
dividing by
minus.
2. Yeah, and well, yeah, the plus or minus is in there as well. So I really think that you have a better opportunity of making mistakes or errors trying to simplify the quadratic formula than you do with completing the square, because in most cases, the answer is already reduced, and there is no simplifying that you need to do. The first 2 problems that we're going to go over are pretty straightforward, and I think like 7 out of the 10 problems from the worksheet that you'll have due on Friday, very straightforward. But then there are 3 that are a little more challenging that make you think a little bit. So 3 of them are nice honors level problems. 2 of them, what we're going to go through today, are basic, and 2 would be good honors level problems to work with. So I've got to make sure that we're meeting all the standards here. Get a little easy to get you used to it, and then a couple of problems that are a little interesting. So the reason we complete the square is so that we have a trinomial perfect square, meaning you have 3 terms and they fit the trinomial pattern. And that pattern is a squared plus 2ab plus b squared. So my first term has to be squared, or a perfect square. The last term has to be a perfect square, but it's the middle term that's key. That middle term, you have to take the first and the last and double it to get to the middle. So if you're looking at this example, we have x squared minus 6x minus 4. Yes, 4 is a perfect square, but negative 4 is not a perfect square. So you can't like just keep it as is and try and work with it because it's not factorable, it's not a perfect square. So we're going to try and complete the square to see if we can like get it in this trinomial form. The first step it says here is to eliminate c. That's the easy step. You got to do that for every single problem. So this is c. We need to take it to the other side. That's what eliminate means. So x squared minus 6x, not doing anything with that part, that's what we're trying to get into this perfect square form, equals 4. And I left a little blank there because we have to add a number to it to make it a perfect square. That number that you're adding is from part 2. So part 2 says take b divided by 2 and square it. B is in the middle, so that's -6. We're cutting that in half, and then we're squaring that number. So really, like, the perfect square is based off of that middle b value. That's how we create the final value. So Brandon, -6 divided by 2 squared is 9. So we add it to both sides to keep it equivalent, +9, +9. And then part C says factor the left side as a perfect square. So Chelsea, if we have the left side, we're dealing with a 9 here. The two numbers that multiply to be 9, that add to be -6 are?
3, -3 and 3.
So -3, -3. If that number is the same, then it's a perfect square. 3 times 3 makes 9, -3 times -3 makes 9. We're going to place that in a quantity squared because it's the same number. So instead of writing x minus 3, there are 2 of them. We can make that power a squared, and then it's factored as a perfect square. So at this point, completing the square process is done. You've completed the square. Your goal is to have a quantity square. At this point on Friday and Monday, we'll be working at this and kind of looking at parabolas in this form and doing some applications with it. However, in this case, the last step says to proceed to solve. If we truly want to find x, we can take this and continue to solve. But the completing the square is now done. Like, we've completed the square, it just asked us to kind of solve the problem for x. So the other goal of completing the square, besides to think of some parabola applications, would be because it's really easy to solve for once you have a quantity squared. Libby, why is this easy to solve for?
Because you just do quantity squared. Yeah.
Yeah, so you just take the square root to eliminate the square, and you just get x minus 3. On the other side, we have the square root of 13. But in front of that, because you put the square root in the problem, you have to place a plus or minus. Good. I think you'll get used to that plus or minus. Like, it'll just be, you always put it there. And then the last thing to get x by itself, add the 3 to the other side. So we will always write the integer rational number first. So like either a whole number or fraction goes first. Then the plus or minus sign should always be in the middle. The square root is like the lowest kind of number. It's like the bottom of the barrel number. It goes last. It's not as important as all the other numbers. So in the hierarchy of numbers, it's on the bottom. That's why it goes last. Yeah.
You said that the square would be like really a lot less messy, but like you still end up with a square root.
Well, yeah, but it's like with the quadratic formula, you would end up with like 3 plus or minus the square root of
B squared minus 4ac over 2a.
I know. What?
39. There's going to be a number underneath here. I'm trying to think of a number that would work. 169. That would come out perfectly. What's 4 times 13? I'm not thinking today. 26, 52? Okay, there we go. I was thinking, it just wasn't quick enough. So like, you would end up like something like this. Like you then have to simplify this. After you simplify that, then you have to simplify further. So, yes, it's still messy. If you can't factor it, you're never going to get a nice number.
Right.
So,
Well, yeah, I understand.
Like- simplify it, already simplify.
I guess I'm just sort of biased.
I'm trying to win you over here, Alice. Brandon.
Underneath, wouldn't it, since it's b squared minus 4ac, wouldn't it be?
Oh, I was not using the numbers up above. I was just trying to come up with a problem where we'd have a square root of 13.
Oh,
no.
okay.
I was not using the numbers up above.
Oh, okay.
So, yeah. Because this should be a 6. And this is going to be something else. I was just trying to write a couple of numbers to show Alice that there is a little more work. Still messy, but a little more work. That was my point. All right, why don't you try the next one? X squared plus 2x minus 8. I'm going to win you over this time, Alice. Except once you turn the page, then you're not going to be, then it's all over. The good thing is that we use completing the square in like multiple chapters. So you'll like it after a while. Maybe. always, always add c to the other side. Then you take your b value, that's the middle value, divide it by 2 and square it. So Michael, 2 divided by 2 squared is?
1.
Add that to both sides. So now we need that quantity squared. So Michael, what goes in the parentheses?
Would be x plus 1.
It would be. Alright, this one's nice because you get a 9 over here, and when you take the square root of 9, you end up with plus or minus 3. Don't forget the plus or minus. So your two answers, positive 2, negative 4. Because negative 1 plus 3 is positive 2, negative 1 minus 3 is negative 4. Questions? This one was factorable. So if you can factor it, technically we could just factor the problem and be done with it. But anytime you can factor, your answer here will be a nice answer. In most cases, they're not going to be factorable because that's why you're using completing the square. If something's factorable, like you'd be like, yeah, I'm going to factor, I'm not going to complete the square. Okay, so flip the page. So at the top of your page, it says some modifications need to be made if there is an a value. So completing the square only works when it's x squared. If there's a 2x squared, a 3x squared, a 7x squared, anything in front of x squared, it doesn't quite work by just like taking b divided by 2 and squaring it. So that works when you have an x value, a 1 in front of your x squared value. So this one we just have to tweak a little bit. The first thing that you still need to do is take c over to the other side. And in this case, it's already on the other side. So this problem probably started looking like this. But the c was taken to the other side to kind of start us off. So you don't have to do that step. Does anybody know what you do next? Libby?
So you would take it, and then so you would take 2 out of it, and then it'd be x squared minus 6x. Or wait, minus 3x.
There you
Sorry.
go.
I had that written down.
Oh, good.
Okay. And then what you would do is you would find it would be negative 3 over 2 squared.
So you're only taking out the coefficient. Don't think of it as taking the GCF out. Yes, on the left-hand side, it has a GCF of 2x. But once you pull an x out, you don't have that x being squared. So we need the x squared to complete the square. So you're pulling out just the 2. This one gets a little messy because we're trying to square negative 3 over 2. However, when you square a fraction, it is not hard. It doesn't need a calculator. Square the top, square the bottom. So remember, like, I will try and get you not to rely on the calculator for like stupid stuff like squaring a fraction. Don't need a calculator for that. There are things that we will have to use a calculator for, other things that I don't want you to try and just like all of a sudden go to it because you feel like you need it, because you don't. You guys are all smart. You don't need a calculator to square 3 halves. So 9/4 goes on the left. There's a 2 in front that I need you to keep and not get rid of because that 2 is the steepness, that vertical stretch of the parabola. And if we try and get rid of it right now, we're losing the shape, that steepness of the parabola. And I know you're not really thinking of it as a parabola because we're just solving at this point. But if I get you in the habit of doing it correctly now, then it'll be better when we continue to work on them. Libby, do you remember what number goes on the other side?
So since there's the 2 in front of it, like you're not technically adding 9 over 4, so you would multiply that times 2, and like simplify that would be 9 over 2 because it would be 18 over 4.
Nice explanation.
And then you would do plus 9 over 2.
Good. So she said, really, yes, you have a 9 over 4 on the left side, but that 9 over 4 is times 2. That new number is actually 9 halves. 18/4 becomes 9 halves. That's what you're adding to the equivalent to the other side. All right, now one more thing here. We need this to factor as a perfect square, and there's a little trick. Yeah, you have a fraction of 9/4. You have a fraction of that negative 3/2. When you squared that, that's how you got 9/4. So if you're trying to complete the square and go back to the factored form, this number here is 9/4 when it's squared, so pulling it back into its factored form, we need the negative 3/2.
Will that always work?
Always, every single time. Because you're squaring it to get 9/4, well, factoring it means I need that same number that made 9/4, and that same number is the negative 3/2. So every single time it works. On the right side, again, I'm challenging you not to grab that calculator all the time. If you have 11 plus 9/2, what is 11?
31.
Yeah, so this becomes 31/2. 11 is really 22/2.
This is from Mr. Wall.
Oh, it's from him.
Yeah.
Oh, thanks. Questions? So this point here, we have completed the square. And like, we'll look at this as a parabola and do some things with it as a parabola. It does say to solve, so at this point we can continue to solve. What do you do with the 2 that's in front, Chelsea?
You divide by 2.
So she said divide by 2, and dividing by 2 is the same thing as multiplying by 1/2. So we're going to multiply by 1/2 because there's a fraction on the right side. So that makes 31/4. And then just like all the others, we take the square root because our goal is to get rid of that squared term. So we have x minus 3/2. And I promise Alice that these don't get overly messy and they're easy to simplify. If you have the square root of 31/4, to square something, we square the top and we square the bottom. To square root a fraction, you look at the square root of the top, look at the square root of the bottom. The square root of 4 is 2. So the final answer, by adding the 3/2 to the other side, don't forget the plus or minus, and then 31/2. Now, this is probably a problem that you'd want to use the quadratic formula for because it has those evil fractions in it. But it's still like simplifying this square root. It's still pretty easy to simplify it. It's just a little rough to work with all the fractions. Questions?
Do you make it so it's like all just like you like make it like together the common denominator?
Oh.
So be, like if you
You
wanted
could,
to.
yes, but we'll talk about numbers having standard forms, and a radical and a non-radical, they actually don't want to be grouped together, so we keep them separate, and that'll be the same like when we work a lot with imaginary numbers. It's gonna have that same pattern. So we usually just keep them separate because they're not actually supposed to be grouped together. In most cases, I tell you to combine those fractions together, but with the radical and a rational, they stay separate. Other questions? So there's just one last problem at the bottom. Kind of working through it again the second time. Please don't divide by 2, even though these numbers are screaming at you and telling you to divide by 2 right away. I just don't want you to get in the habit of dividing. This dividing changes the parabola. And think of this as a graph with a vertical stretch. So yes, I know everything is divisible by 2. We could just reduce it, make it a little nicer. But I want you to not start that habit. Take the 6 to the other side, then factor out a 2. So Brandon, -5/2 squared is?
25 over 2.
Nice. How about 25 over 4? But on the other side, you're adding 25 over 2. is 2 times 25 is 50/4. That reduces to 25 over 2. Hey, the little cheat here, Eris, what goes in the middle when we try and factor? Exactly, the -5 over 2. And then the -6 has a common denominator of 2. It turns into a 12. -6 is really -12 halves. When you add 25 to that, you get 13 over 2. No. So 2 final steps here. Get rid of the 2 in front. Because we're solving, now you're allowed to get rid of it. Multiply it by 1/2. And then finally take the square root. So your answer, adding 5/2 to get x by itself. Don't forget the plus or minus. We have the square root of 13. The square root of 4 becomes 2. Questions? So when you open your packet up like a book, you'll see the next page has some problems completing the square. I sent the solutions through Remind about an hour and a half ago. And you have about 6 minutes that I bet you could probably get the first 2 or 3 because they're pretty straightforward. Probably could get a handful of those done. There is a back, there's 10 problems, so 6 in the front, 4 on the back. It will be like the last couple that are a little more interesting. And that's due on Friday. So tomorrow you have a test. Make sure you're reviewing tonight, looking over those worksheets, peruse through your packet. There's probably a couple of things that didn't make it to the review worksheet. Just kind of look through the notes that we did in class. Maybe a homework problem that you got stuck on. You wrote it at the top of your page. Look over that. Homework problems sometimes appear on tests.